Okay, let's get right into 3, 2, 1. Slope as rate of a change. First thing I want you to do though, let's pause this, and I want you with a partner to brainstorm some ideas. And I want you to think of the word slope that you learned last year, right? What do you think of when you hear the word slope? I want you to write down some examples just with the people around you. No reason to get up and move around per se, but just write down some of the things that you think of when you hear the word slope. And then once you do that, we're going to talk about some of the examples of slopes that you might have seen before, right? And do the same thing here for the second box. What do you think of when you hear the word rate? Okay, rate. Okay, so write down some examples or some ideas of what you think of, and maybe some examples of rates that you have seen before. Do that as a class or just the people around you. If you're watching this video early, then just try to do the best that you can. Okay, go ahead and pause the video now. Okay, and so now, hopefully you guys have written some stuff down. What do you think of when you hear the word slope? I think of maybe like a mountain, right? Or rate of change, but that's of course me because I'm a math teacher. But I think of rise over run. Okay, I think of all those different things, right? And maybe like a fraction or a graph. Okay, and so some examples of slopes that you've seen before, you might have seen m equals, y2 minus y1 over x2 minus x1. You might have seen where you have m is in the slope-intercept form with the equation where m is the slope. And you might have just seen it where it's a fraction, right? Like 3 over 2 or something along those lines. Okay. Then, of course, the word rate. All right, rate you might think of like what's the going rate, like money maybe, right? Or maybe it's a speed or velocity, velo. Maybe it's just a ratio, right? A rate, like 5 miles every hour, right? Something like that. So examples of rates that you might have seen before or something like that, you might have seen 5 to 1 miles per hour. You might have seen like, I don't know, it is $10 per hour, right? And so those are some different examples. If you haven't gotten those, maybe go ahead and write those down. And that just leads us into what the definition of slope is. The definition of slope is a line. The slope of a line is a ratio, right? So like a fraction or a decimal that represents a line's steepness and direction. So steepness meaning like how quickly it goes up, or how vertical we'll say how vertical. Okay, and then direction, obviously, whether it's left or right or positive or negative. Okay, and so slope is the rate of change. Slope is the rate of change. Okay, finding slope from a graph. So slope on a graph, we already talked about this actually up here. There's a couple ways you can look at it, but we look at it as the change in y values over the change, my handwriting's awfully great today, in x values, which we are more familiar with rise over run. Okay, so you've got, and this can also be written as, so the change in y values over the change in x values, just so we're aware if I happen to write this. Sometimes I put like this, where you put like a little triangle. Okay, and that means change as well, right? So you got the change in the y values divided by the change in the x values. So when you're looking at a graph, you're looking at the rise over the run, or y over x, okay? Also, you can do it with the formula, which is up here, okay? All right, let's go ahead and find it, though, on the graph. So you have positive and negative directions. So if it's a positive direction, then it's going to be positive over a positive. If it's negative, right, or it could be this, negative over a negative, For negative directions, it's going to be a negative over a positive, or depending upon how you count, positive over a negative, right? And so when we look at this first example, it says, what is the slope of the graph? You can see that we are going up 1, 2, 3, because we always do rise first, okay? Rise first. So we go up 3, that's a positive, and then we go right 1. So our slope here, or our m value, is going to be 3 over 1, okay? Now, if you want to go ahead and pause and try this one, you can, or we can just do it together. I'll give you a moment here to decide. Okay, so slope from this graph, again, we always do rise first. It's not a requirement, but I just think you're less likely to make a mistake if you do it this way. So we're going to go up or down. Well, in this case, we go left to right still read a graph the same way we read a book in English. Okay, and we go down here, 1, 2, 3, 4, 5, down 5, and right 1, 2, 3. Down 5, right 3, rise, over, run. Okay? And that's how you find slope from a graph. Pretty easy. Okay, so now if you have 2 points, this is where the formula comes in, because we just don't have that visual component, right? So oftentimes you'll have 2 points, and they aren't labeled like this, but this is how we're going to label them, x1, y1, x2, y2. And it's always a subscript, because we don't want to get it confused with x squared, right? That is something different than this. Okay, so we use it, it's what it's called is a subscript. If you were on like Microsoft Word, you would look for it says subscript, right? And that just says that this is the second x value. So this is the second x value, and this is then, of course, the second y value. Okay, so slope from 2 points is this, y2 minus y1 over x2 minus x1. So notice I'm subtracting the y's and I'm subtracting the x's. Where I see most mistakes is students will have a y value up here and then they'll subtract an x value. So make sure you're pairing the y's, right? The y's. So the second number in each of the parentheses or the ordered pairs minus the first number. Okay, all right, and that's going to give us our change, our change in y over change in x. So again, method, let's get used to writing it down. M equals, the slope equals y2 minus y1 over x2 minus x1. Okay, now we have to be careful because we got some negatives in here, but that's all right. So we're going to go ahead and label these. So you got your first x value, your first y value. Make sure you have nice, neat handwriting so you can read your own handwriting when you're putting these down. Sometimes your x's and y's can look the same, right? Okay, y2 is a negative 3. We're going to substitute that in for this one. So we got negative 3 comes first, minus, because the equation has a minus, y1. And y1 in this case is a negative 18. Okay, so we got negative 3 minus negative 18. Okay, and then on the bottom we got 15 minus a negative 4. So 15 minus a negative 4. And as we talked about so frequently, 2 negatives when put together make a positive. So negative 3 plus 18 over 15 plus 4. Okay, and that simplifies. Negative 3 plus 18 is 15 over 19. Okay, these numbers do not have anything in common, so we're not able to simplify them, so it's just 15 over 19. Okay, and that might happen, remember? So that would mean we would go up 15 and over 19. That's a pretty big slope. What is the slope between these 2 points? You can go ahead, again, pause if you'd like, or just go ahead and try it with me. First thing we're going to do is label it x1, y1, x2, y2. Okay, and again, this looks like an x, so here I am not even following my own advice. There we go. So now we go 2 minus 13 over negative 19 minus a negative 11. Okay, when we combine those, 2 minus 13, 13 is a bigger number and it's negative, so that tells us our top's going to be negative. And then negative 19 plus 11, which simplifies to negative 8 And again, these do not have anything in common, but we do know that two negatives, when dividing, make a positive. So this is really the same thing as saying 11 over 8. Okay? All right, and that's how you use slope formula. Okay, and then we got a couple different things left here. Slope from a table. All right, so this is where we kind of saw this before, where we did linear functions, if you remember, right? So you basically find the change in y and do it divided by the change in x. So if you have a table, you got x and y, right? And you're going to find those differences and then put the change in y on top over the change in x. So in this case, we go, let's see, plus 6, plus 4, plus 2, and then plus 6. Okay, I didn't have the best handwriting on this, but you guys understand the point. Then we go up 3 on the left, up 2 on the right, up 1 on the left. Or I mean, it's all on the left. I don't know why I'm saying on the right. Okay, and so now we take that difference in y and we put it over top of here. So we got 6 over 3, we've got 4 over 2, we've got 2 over 1, and we've got 6 over 3, which you can tell 6 divided by 3 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2, 6 divided by 3 is 2. So our slope is 2 over 1. Okay. Again, go ahead and pause if you'd like, or we'll do it together. First one goes minus 3, minus 3, minus 3, minus 3. So yes, these would both be linear. Plus 1, plus 1, plus 1, plus 1. So definitely linear, and in this case, they're all the same, so it makes it nice. We have the slope is negative 3 over positive 1. Okay, you don't have to put the 1 on the bottom, but if I were to graph these, I'd want to be able to see that this is the slope and this is the rise over run. So that's the only reason why. I would also accept m equals negative 3 or m equals 2. Those are also valid solutions. Okay, so different types of slopes. You have a couple different, right? First one you have, of course, is a positive, right? Slope looks like this, where it goes from left to right and goes in an increasing fashion. So we could say positive or we could say increasing. Okay, just like last week. Next one we would say is decreasing. And that's a negative slope. Looks like this. Okay, we've got, we talked about this last week as well. We've got a constant slope, which is actually 0. Okay, if there's time today, maybe Mr. Figgle, or you can look up Slope Dude on YouTube and watch that. But you have constant and a 0 slope, which is a straight line left to right. And then the last one that we haven't talked necessarily about is the special ones down here, right? Which is a vertical slope, which is, this is called a undefined. Okay, and an undefined slope looks like this. Okay, so let's talk a little bit about that and what that means, right? So a horizontal one, which we just saw, that's a 0 slope, it's constant. So just be aware, like from a terminology standpoint, constant, right, just means the type of slope it is, right? Or the type of line it is. It's a constant slope. However, the actual value for that slope, like if I were to say m equals, it would be 0. If I were to say m equals here, it would be undefined, right? Whereas these ones, it's going to be some positive number or negative number, you know what I mean? Negative over a positive or something, and this one's going to be a positive over a positive. Okay, but with special slopes like the horizontal one, the graph looks like a straight line across. Okay, which means that it doesn't go up and down at all. So that means the y-axis doesn't change, right? So that means you would have something like, let's say you have the 2 points, 2, 0, and I don't know, 5, 0. Okay, so if you subtract the two y values, you're going to have 0 minus 0 over 5 minus 2, where you have the change in y over change in x, which gives you 0 over 3, which any 0 divided by any number is still just 0, right? And so that's what that looks like. Okay, where you have 0 in the y values. And same thing when you're trying to find the slope, right? Like if I'm going up and down, it's going to be 0 over any number. So I'm going to just put the number simple. And a vertical, kind of the same idea, right? But now instead it's changed. So now notice that your x value, it's maintaining the same x value every time. It's not going left and right. So that tells you in terms of a coordinate point, it's going to be something like 0, not even 0. Let's just say it's 3, 2, and 3, 7, right? So now you have 7 minus 2 over 3 minus 3. Well, now you have 5 over 0. And if you put that in your calculator, you'll see that you cannot divide by 0, right? It gives you an error code. So that is undefined. So your slope for that is always going to be undefined. And it's going to be some number over 0. And that's it, right? Okay, give you a moment to go ahead and copy that down. Once you are done, I know this is a little bit longer of a video, especially for something that's kind of a review from last year, but students have struggled with this in the past. So once you're done, I want you to go ahead and try these out. You're going to find the slope of the line. That's it, just the slope of the line. Make sure to reduce your fractions, okay? And then down here, you're going to use a formula. Down here, you're going to use the tables. So this is where you'll do this. Have it checked off, and then there's a Canvas quiz for you to check your understanding, okay? Good luck. Send me a message if you have any questions, and I'll see you guys soon.